What's up guys, in this video I'm going to explain my code used in my ESP8266 project where I control 5 relays through the web or with push buttons. Make sure you watch the video where I show the working project and explain the circuit, and you may also want to watch a time-lapse of me soldering the components to a prototyping board. In the description you can find a link to my code and you can use it, modify it or publish it on your website as long as you provide a link to my channel. Alright guys, I will assume that you already know the basics of coding. If you don't, I suggest you watch some beginners tutorials. They are all over YouTube. Just search for Arduino beginners tutorial and you will certainly find them. If you just want to copy the code, you need to change the network name to your wireless network name and also the password. You might also need to change the IP address. This is the address you type in your browser to get to the web page, and you might need to change the gateway and subnet mask. I recommend setting a static IP this way because it connects a lot faster to the network, and this way it's a static IP, so it doesn't change. But if you want to get an automatic address from your router, you can delete these 3 lines and also this line right here, this. Okay, and that's pretty much what you need to change. Now to the code explanation. Here we have the refresh rate of the page. The default refresh rate, as you can change it anytime in the web page, but every time you turn on the ESP, the default refresh rate is, in this case, 0, which means disabled. Here is the relay pins array. These are the GPIO pins that I'm using. 13, 12, 14, 4 and 5. I'm not going to explain all the variables, they are all commented, but if you have any question, leave it in the comment section and I will do my best to explain it. Now, this is the Wi-Fi connect function. As the name might suggest, it connects the ESP to the Wi-Fi network. And it also prints some information to the serial port. Here it prints a dot every half second until it connects or until it times out, it fails to connect, which happens in 5 seconds or 5000 milliseconds. In case it connects, it prints Wi-Fi connected to the serial port. It starts the server, and it also prints the IP address. This is useful if you are getting an IP by DHCP, since you might get a different IP every time you turn it on, every time you turn the ESP on, depending on the configuration of your router. But if it fails to connect, it prints connection error, and it keeps track of the fail time, and it also sets the did fail variable to true or 1, which means the same. I will explain this in just a second. Now the Boolean function, the debounce function is used to debounce the buttons. Every time you use buttons with a microcontroller, you should debounce them, which means you only read them. You only read the, in this case, the analog pin every whatever button delay value is set to, which is in this case 300 milliseconds. If you don't use this debounce function, you might get an unstable code which turns on different relay pins than the button you pressed, or it doesn't even work. so you should use it. Now for the setup, I'm setting the relay pins as output and setting them to low, which means every time I start the ESP, the relays will be off. You can change this to high, but you also need to change the status variable, this one, to high. Now here I'm starting the serial port and calling the Wi-Fi connect function, which connects the ESP to the Wi-Fi as we seen earlier. Now in the loop, which is the part of the code that runs over and over again, I'm first checking if the Wi-Fi is connected, and if it didn't fail earlier, this is the variable we've seen here. So if it didn't fail, which is this case, it connected, it tries to connect right away. In case it did fail, it just tries to connect 15 seconds later. I had to implement this delay because since the loop runs very fast and the Wi-Fi takes about 4 seconds to connect to the network, I mean the ESP takes about 4 seconds to connect to the Wi-Fi, it would get to this state and try to connect again, so it would never manage to connect. I hope I was clear in that explanation. If not, just ask in the comments. Now here I'm reading the analog pin and storing the value in the analog variable. If the debounce function returns true, which means 300 milliseconds passed between the last button press, and the analog value is between 100 and 250, the status of the first relay toggles, which means if it's high it gets low, if it's low it gets high, and also the status of the pin gets high or low depending on whatever happens here. I also keep track of the time the button was last pressed, which is used in the debounce function. It's always sent to the debounce function. Which, if I didn't explain, the debounce function returns true if the time is greater, if the time that has passed since now and the button last pressed, or the button last pressed and now is greater than 300 milliseconds, it returns true, else it returns false. For the other buttons, it's the same thing. I also print on the serial port which button was pressed and the value. Only thing that changes for the next buttons are these values, which if you use the same resistors that I used in my voltage dividers, you shouldn't need to change this, but you might need to depending on your wires you used and the push buttons. So if you press a button and a different relay turns on, you need to change these values. I will provide a little code that prints the value read by the analog pin to the serial port, so you can read the value of each button and change these values accordingly. Okay, if there is no client available, it delays 5 milliseconds and it restarts the loop, which means everything below this line doesn't run. In case there is a client available, it prints new client to the serial port, and it waits for the client to send some data. And since I'm using a while loop, I set a timeout, a 300 milliseconds timeout, so the code doesn't stop here. In case I should say the program doesn't stop here in case something goes wrong. Here I'm reading the string sent by the client and storing it in the request variable. I'm also printing the request to the serial port, and here I will begin to match the request. So if the request was relay1 equals on, I turn the relay1 high or on, and I also keep track of the status. Yeah, and it's basically the same for every request. High or low, if it's off it's low, if it's on it's high, of course. All relays off goes through all the relays and turns them low. Or if it's on, turns them high. And here, this is the HTML code, which I'm not going to explain, it's just basic HTML. If you have any question, just leave it in the comments and I will explain. Yeah, and that's pretty much it. Hope you enjoyed this video, and if you did, please thumbs up and subscribe to my channel. Have fun!